As we come through the air filter with our air, the first thing that the air meets is this, the mass airflow meter or the mass airflow sensor, MAF sensor. And this is a super critical sensor on the vehicle because the engine uses this, the ECU, the PCM, the computer systems use this sensor to detect the amount of air that's getting into the engine. So the ECU needs to know the amount of oxygen going into the engine in order to match that with the amount of fuel being injected. So the ECM, the PCM control the injector timing. Injector timing is how long is the injector pumping fuel into the engine. That determines the amount of fuel entering the engine. So the ECU uses this mass airflow meter or MAF sensor to work out how much oxygen is actually getting into the engine. What's the volume of air, the airflow traveling along here? So every fuel injection system will have a mass airflow meter, or there's another type of sensor called a manifold absolute pressure sensor or a MAP sensor. They both do basically the same function. They're determining how much air is getting into the system. So a MAP sensor, manifold absolute pressure sensor, would be on the manifold and it senses the pressure in the manifold. But what we're going to talk about today is this, which is the mass airflow sensor, which detects the flow into the engine. So we'll pull this off and we'll go and have a look at this on the bench. What we've got is we've got a little rubber sealing ring here so that the airtight seal is maintained between the filter housing and the sensor. Because as we said, once we're beyond this sensor, we don't want any unknown air getting into the system that the ECU doesn't know about. This is like the bouncer of the airflow world with a counter, counting people in and out. Anyway, let's have a look at this. One MAF sensor. Now, all these sensors, incidentally, have three-letter acronyms, and they're standardized, and they come from the OBD2 standard. So that came out in the mid-90s. Before that, you'll find these sensors called all sorts of different things. All sensors had manufacturer-specific names, but now everything's standardized on these three-letter acronyms, and for us, this is the MAF sensor, MAF. So, how does this thing work? Well, the air travels through it, and the air, in our case, travels through this way. You can actually fit these. If we pull this sealing ring off, you can see this would fit either way. And if you fit it the wrong way, the reading's going to be inaccurate and wrong. So on the side, you'll see we've got a little arrow which indicates the direction of flow. So air flows through this tube, and in the middle of here, if you look inside carefully, what you will find is we have a tiny little wire suspended in the airstream. In our case, it's actually what's called a hot film detector, but you can imagine it as a little wire that hangs down inside the airstream. So, and that wire is made of platinum or some superconductive heat-sensitive material. What happens is the ECU puts a voltage into that wire and heats it up. And alongside the wire we have a thermistor or some sort of resistor that will sense the temperature of the wire. So what we want to do is the wire is heated up to a certain temperature. Let's say, for the argument's sake, 500 degrees. Doesn't matter. Fahrenheit, Celsius, university degrees, whatever, who cares? 500 Celsius. As the airflow blows through there, it's going to cool the wire because it's sitting in a stream of wind, essentially. The more airflow we have going through there, the greater the cooling effect is going to be. So it's going to want to reduce the temperature of the wire. So say we put 5 volts in here, and that gives us a wire of a temperature of 500 degrees. If we boost the amount of air flowing through here, really open the throttle and we're pulling in a lot more air, then let's say the temperature of the wire is going to fall to 400 degrees, say. To maintain the temperature at 500, which is our reference temperature, the temperature that we're aiming for, the target temperature, is going to require more electricity. So the system here, this is sort of onboard circuit on this sensor, will pump a little bit more electricity into there and raise the temperature. So by measuring the amount of electricity it takes to heat the wire to our reference temperature, tells us the amount of cooling that's happening to the wire, and by derivative, the amount of airflow that's flowing alongside that wire. So essentially, by heating this wire up to a certain temperature and measuring the amount of electricity it requires to hit that temperature, we know the airflow travelling through here. Now the ECU then takes that reading. Essentially it reads the resistance of this sensor here and constantly uses it to calculate, using a reference table or some sort of formula, calculation, function, whatever, uses it to work out, given this resistance, how much airflow is travelling through this sensor. And that data will be provided by the manufacturer. So they'll tell you a resistance of 100 ohms gives an airflow of 20 cubic feet per minute, something along those lines. So this thing is essentially measuring the airflow. The thing to note with these is that they account for the temperature of the air, because we're interested in the temperature of the air because cold air is denser, contains more oxygen per litre of air, say. Now, cold air will also, incidentally, cool this wire more because it's colder. So we have if you're sitting in a cold wind, you get chilled more than if you're sitting in a hot wind. So the cold air blowing through here will have more of a chilling effect on the wire, will require more electricity to heat the wire to its reference temperature, and therefore the mass airflow meter will detect that there is more air flowing. So effectively, cold air will be read as a greater flow of air. But in either case, that's accurate for what we need because the cold air has more oxygen, so effectively we have more air flowing into the system. So that's one reason why these are very, very popular. So what we've got here is a hot film type of mass airflow meter. There's also the hot wire type. So the film has almost like a little circuit board in there which contains heat sensitive wire, heating element type thing. The hot wire is literally what it says on the tin, so it has a hot wire running through the sensor here. Both of them work in almost exactly the same way. There's a third type of mass airflow sensor, an older type, the predecessor to this one, which used vanes. So it used kind of flaps in the airstream, and as the wind blew through the tube here, our chamber, that flap would be forced open or it would move in some way, and a resistor, variable resistor, would detect how open is the flap, how much force is being applied to the flap by the air. The problem with those was that they blocked up, they caused a restriction in the airstream. Now even this one, if you look carefully inside, we've got a fair old amount of plastic inside here which is going to restrict the airflow somewhat. So that's one reason why MAP sensors, manifold absolute pressure sensors, are used, particularly on high performance engines or engines which are using forced induction, turbochargers, superchargers, something like that. Those MAP sensors are used because partly they work better in that situation, but also they don't in any way block the airstream into the engine like this does. And the output from those is used in the same way as this to work out how much fuel do we want to put into the engine. And alongside this, you will often find one of these mass airflow sensors which incorporates a temperature sensor for the air. Now in our case, we can look at the number of pins here. We've got 3 pins on this sensor. So we know, partly we know because we already talked about the IAT, the temperature sensor, intake air temperature. We know that that is situated on the air filter housing. But if we weren't sure about that, we just found this in a box of parts. With 3 pins on here, we know, as we're going to talk about when we get to ECUs and we get into the actual electronics inside here, we know that with our 3 pins we have a reference voltage that comes from the ECU, a ground and a signal wire. So those are the 3 wires that give us the reading from our mass airflow. If there were 5 terminals there, then we would probably be thinking we have another sensor on here. Most likely it's a temperature sensor for the air, because those 2 things go hand in hand. Okay, I'm going to pop this back on. Now, having said that, some vehicles use MAP sensors, some use MAF, some use both. For extra accuracy or for whatever reason, they may have both sensors. These MAF sensors are super accurate. They're very, very accurate. They're kind of a miracle of sensing technology on vehicles. So we'll install this. Have I put this on the right way? Absolutely not. That goes on this way. See, our reference arrow is of use. Incidentally, we've got in here a little plastic grid. I assume that's just to prevent any huge contaminants from blowing in here and damaging the hot wire. How you would end up with huge particles that would be trapped in this grid at this side of the air filter, who knows? It seems like a bit of an unnecessary restriction on the air in there, but never mind. Right, we'll reinstall this, we'll move on. What will we talk about? Throttle bodies, I think.